there's a little time lapse for you. It's really amazing we can send up a drone to 150 feet when the winds are gusting up to 20 miles an hour, and yet it's stable enough to get a tripod type shot. Yeah, technology has really come quite a ways. But we finally have some very dynamic weather in place, some big changes coming, and we have a front in the area. In fact, that's it right there. The 250 millibar chart is the key to the pattern. Here we're looking at North America. There's a large long wave ridge on the west coast right about there, and a large long wave trough centered in the central U.S. So this pattern is kind of built by a lot of cold air across the continental regions, and then kind of a warm anomaly across the west coast region. The warm air tends to build the heights, and the cold air takes away from it. And also a lobe of the polar vortex centered around Churchill, Manitoba, right about there. And then in between, we've got this jet stream flowing southeastward from British Columbia into Nebraska, Iowa, and out across the Great Lakes towards Quebec. And as a reminder, when I read off these geographic areas, I'm making mental notes. So when I turn to other charts, I've got kind of a verbal train of where these different features are, and I can instantly see where they're at. That can be very helpful when we start looking at the surface pressure and thickness in the lowest 3 kilometers. So referring back to that description of the jet, coming down from British Columbia towards Nebraska, out over the Great Lakes into southern Quebec. And notice how that places the jet pretty much on the north side of these thickness ribbons. There's a bunch right there, and there's a few more out here. And that's where we expect to see the jet. Usually right over the thickness ribbons, but occasionally poleward of those features. So we definitely have good thermal consistency between the upper levels and the lower level patterns, and we expect to find the fronts roughly like that. Now likewise, we can find the 850 millibar front. It's going to fall in a similar pattern, but a little further back towards the cold air. Not always, but typically that's where we find it. Also a 700 millibar front. Yeah, that's certainly the case. Looks a little more complex though. I do find one gradient right there. There's this other little feature going on here. I don't really know what that is. That looks like it's kind of out ahead of the surface front. And when we find colder than usual air in the mid-levels out over the warm sector like we see right here, that's a good indication that there could be some instability. Doesn't look like a whole lot of it there, so I would probably want to go in and look a little closer at the data. And then there's probably this other little frontal feature here. I haven't quite resolved that, but man, look at that cold air flowing out of Canada. That's about minus 20 Celsius. And then we go up to 500 millibars, and yeah, that's a mess of cold air for sure. And the 500 millibar chart, that's a lot of cold air up there. The leading edge of the cold air, that's going to be the cold front, which is, I guess it's going to be somewhat like that there. I can probably pick out one boundary there, maybe another here. I guess the more significant boundary is out ahead of it, and that's probably one reason they're getting some of that mid-cloud developing in West Virginia. And that was the 12Z chart. It's already well past that, so that's a lot of the cold air flooding into West Virginia in the mid-levels. And let's take a look at a couple of Skew-Ts. Let's try Chicago. Lots of cooling, mostly through this layer right here. There is some slightly warmer air up at 500 millibars. We go a little further northwest towards La Crosse, Wisconsin. The air mass definitely gets cold through a considerable depth. Look at that low tropopause. And then we get into the heart of the cold air mass around, let's see, around Minot, North Dakota. Yep. Almost dry adiabatic there. That's a very steep lapse rate. And top of the troposphere, about 28,000. So if you're in an airplane going from Boston to Seattle at 35,000 feet, you're going to be in here, which puts you in the stratosphere. So you're probably going to be breathing in some ozone, whether you like it or not. There's the surface analysis at the Sour for the southeast U.S. That cold front approaching the Appalachians, moving through Nashville to Sour and into the Shreveport area. And I analyzed a wave on that front, and a wave is where we have a kind of a discontinuity. You don't see it in the isobars. This is why you got to do your own analysis. You got to fill in gaps that the computers might have missed, and you can see the 12 isobar like that, the 16 isobar like that. But there is a low right there. Notice how the pressures go from 1012.8 and 1013.3 down to 1012.3. That's like a drop of about 5 points or so. And then they pick back up around Dallas. So that's a pressure deficit right in that area. And we can pretty much extrapolate that back to that low right there. I can't read that number under there, but I'm pretty sure that that's where the low is. And we've got that counterclockwise flow to the air. So that's pretty much all the support you need to place that low. Does the SPC automated analysis pick this up? Because this kind of thing is important during a severe weather day. You've got to pick up on all these waves and mesolows. So here we have the SPC mesoanalysis graphics, and the product, I haven't done this in a while. I guess we've been out of severe season for a long time, but velocity tensor magnitude. That's one of the quantities for measuring the stretching of the air, and I can use that to kind of outline where the front is. Looking at the wind field, it's hinting at that low right in here. See that right there? So that kind of confirms what I have on that surface map. But really, to find that low, I need to go into the vorticity, and that's not upper level vorticity. This is pure low level vorticity, not counting the Earth's rotation. It's basically relative vorticity, if you want to be technical about it. So the highest values, if we haven't used this in a while, we have to check the legend to make sure we're doing it right. So vorticity is the fill color. So that's these green shadings, yellow shadings, and so on. And the convergence and divergence, that's the actual isopleths. So we got to keep that distinction in mind. So what I'm looking for is kind of a bullseye pattern. I'm not really seeing it. There's one little bullseye right there, another bullseye right here, but not really where I have that low. So there actually may be a little bit more detail in this field than I'm showing on that surface map. Maybe something like that. Maybe another low up there, kind of a warm front like that, and a cold front. So, kind of a deal like that right there. So I think that's what could be happening. To confirm this, of course, we would have to go into the Mesonet data. The satellite showing the advance of that front. And you notice how most of the clouds are back behind the front. So it actually has some anafront characteristics. I'm not 100% sure about that. I'd have to evaluate the mid-level flow. But this has kind of the look of the front being down here. Remember, it goes through Memphis, down through Shreveport, and so on. And I think there's some overrunning over that frontal surface. So tentatively, I would classify this as an anafront. There could be some other processes going on. And then out ahead of it, lots of tropical air and a couple little boundaries lurking in there. And this time of year, there could be some showers developing during the afternoon. In the northeastern U.S., they're getting that front too. And in fact, there appears to be a little bit more instability. Let's go back a few hours. I'm going back a few hours because the sun angle is a little bit lower and you can really make out the shadows. See that right there? There's some decent cumulonimbus towers embedded in that stuff. So some heavy showers, maybe some very light thunderstorms from Quebec down to Ontario, and that's probably due to destabilization associated with a jet stream flowing through this area. I would expect there's probably a left front quadrant right in this region. And we're probably getting some enhanced dynamics with that. And that does appear to be the case. It helps to draw out the location of that jet. So there it is right there. And the enhanced left front quadrant is going to be working this area here. Another way we can confirm that is to look for the transverse circulation. There's probably some acceleration of the 850 millibar flow across New England into Quebec. So we'll go to the 850 millibar temperature and wind. And yeah, we do see that. It's a little bit out ahead of the system, but that's it right there. 50 knot flow there, almost a low-level jet. So where's that warm front? 72 around Washington, 65 in Scranton, back up to 72 in Albany, or no, that's Bennington, Vermont, somewhere in that area. And then it looks like it falls off into the 60s around Quebec City and down into the 50s just north of there. Let's take a look at the coast. 68 around Providence, 70 at Boston, 61. Okay, it's fallen off and then back up here around Bangor and then back down to 55. So it's not really clear cut, but I think that front is going to be somewhere in here. And that gives me my analysis as shown. The warm sector almost all the way up to Montreal. In fact, yeah, 66, that's probably kind of warm for that area. So that kind of drives. And the 850 millibar flow, the transverse circulation feeding up into the left front quadrant, which is through this area. Yeah, that all matches up. So if we had a little bit more moisture, which we don't, see those 40s dew points, that's not much moisture. If we had more moisture, we would expect to see a good chance of severe thunderstorms in the Maritimes and up the St. Lawrence River Valley, but not today. And then back to the west, a couple cold air advection troughs moving through the Great Lakes. That appears to be one right there. Maybe a second one, possibly somewhere in there. And temperatures below freezing, even in the middle of the day around Lake Superior. The northwestern U.S., well, we know that there's been a lot of cold air moving down from Canada. So what's with all these clouds? We would expect to find clear skies and high pressure. Well, a lot of this is tied to the very, very strong cooling in the mid and upper levels, and that gives us a cold, over-warm situation. It's still October, so there's still strong surface heating. You can see through those breaks, there's plenty of sunshine in Montana, even between the cells, lots of sunshine. So that gives you your heating. You get steep lapse rates and strong convection. And you get kind of a showery pattern alternating with sunshine. It's almost a cold core pattern. And there's the surface map. Even though temperatures are cold in the 30s and 40s in Montana, it's minus 30 Celsius up at 500 millibars. So it is still convectively unstable. The main high pressure area, it's centered on the Seattle area, but a lobe extending all the way down into the Central Plains with this other high around Cheyenne. Anywhere east of there, we got that strong northwesterly flow advecting that huge mass of cold air. And anywhere to the south, it's kind of indeterminate. You know, it's kind of a vaguely northeasterly flow. But it looks like that cold air has infiltrated some of California. Let's take a look at that. Well, this air mass is definitely more mild out west, and we can see that by the 66-degree reading at Tonopah, even with a north wind. Reno at 56. That's cool, but not particularly cold. And that's because a lot of this air originated from the Pacific, whereas a lot of the air in the central U.S. originated from Western Canada. It's more of a continental source region. And you can see the drier dew points, 18 Celsius, 24, compared with slightly higher dew points, 20s and 30s out west. Down to the south, that cold front has advanced through Las Vegas and Kingman, Prescott, Winslow, but not quite to Phoenix, where it's still 83. This cold air should continue pushing south and maybe moderate conditions a little bit in that area. The satellite loop showing good conditions in the southwest U.S. Not much to see. That's a little interesting feature right there. It looks like a mountain wave. That's over the Capitol Reefs area of Utah. And elsewhere, that front coming through West Texas as a dry front, and it's already past El Paso. Not much reflection in the lower levels, but it is there. And that'll do it for this edition of Forecast Lab. Just to give you a heads up, I may be taking next week off. I'm planning to meet up with family for the first time since March. We've all been in a strict quarantine, so we don't get into any trouble. And the plan is I'll be back after a few days, and we'll return Forecast Lab back to normal. But we will be back tomorrow, so hopefully we'll see you here. Okay, take care and have a great Thursday evening, and we will see you tomorrow. Bye-bye.